Hello everyone, I hope you can hear me, and welcome to the 15th episode of the Amiga 68K assembly programming course. It's a long way, 15, that means I did 30 in total, 15 in English, 15 in Italian, which is quite a tough thing, let's say that. I'd like to say thanks first of all to Fabio Ciucci for letting me doing this stream using his book. Basically, this is where we were last week on the Amiga. What we last did is where we ended. So basically we have an image and we have text on top of it by using some kind of trick. It's a 4-bit plane image. Our image of Amiga is 3-bit plane itself, and then our text is one other bit plane, but it is bit plane number 4. So all the colors of the image were done so as all the text is shown. Let's switch to the book. So we are, okay, we did 6F. Okay, that was the last one that we did. From here, we continue till 6M. Okay, one example after the other, showing you what Fabio did basically. Let's start with 6G. Okay. So read 6G. I need to switch you guys also on the Amiga. Okay, and 6G. Where is 6G there? Okay, we assemble it. And there you go. So this one, believe it or not, Amiga has transparency. And as you can see, it is showing the same image, but with transparency on top of the image. So you can see that when the colors collide with a certain color, they get brighter. Okay. Remember, the image that we are using here is not the actual image that was with the book. The reason being that at the time when I started using the book, or I thought that the image was not included properly, or it had some bugs, let's put it this way. But actually it was me. I was using the wrong library to decompress the image. So that's why I thought the image was corrupted, but actually it's not. And I actually managed to extract it, and I'm going to show you what the actual image look like, and then we return back to this this one actually, because it's interesting to know when he talks about the image which one he is referring to. So let's find 5G. It's the only one that I did with it. That sorry, yeah, it is 5G, but 5G2. 5G2. 5G, this one, 5G2. That's the real image that he did, that there is that comes with the discs. Okay, so imagine instead of my image, this image. Okay, unfortunately I as I said, I started using my own image because I thought this one was corrupted, and to go back through all the examples and change it, it's too much work. But of course, I will be providing this with the sources. For those that do not know, the sources. Ciao Dario. The Yeah, this we did it. Actually, this was chapter 5, Dario. So we are in chapter 6. So can you imagine how much more, how many more things we will see? What I was saying is that the sources, okay, the sources with my notes. So the sources of the book are available on Aminet, okay? Remember, you can download them from Aminet whenever you like. Just search for Amiga assembly course and you will see it, okay? The other thing is that my notes, okay, and the extra sources that that I am doing, they will be available for those that are on Patreon, okay? Eventually I will release them also, but till then they will be for Patreon users only. Also, the videos, they go to Patreon first, and then you can see them on YouTube. It's fair, no? People that support me, I think they should receive um, such things before. Trying to be fair here. Anyway, so yeah, this is what we did in chapter 5 about 2 weeks ago. So now let's go back to chapter 6 and continue with 6 FG 6. I need to sort. F6G. Now, as I said, instead of my image, imagine that image that you just saw, okay? The reason why, you know, the effect is not, I mean, although you can see transparency, okay? It is, how to say, I think with the real image that I just showed you, it would look better because it has better gray levels. It doesn't look that nice, but anyway, you can still see the effect of transparency on the Amiga. So for those that thought that Amiga did not have transparency, I'm just going to tell you that your OCS or ECS Amiga can do transparency. Maybe it wasn't that obvious, but it is there. Okay, and all he did, I'm just going to show. So don't think that there is any change in the code from the previous example to this example. It's the same code. All he did is change the colors and made them more, reflect the combination of the image. By the way, this also has the option to scroll the text up and down, and basically you can see the memory of the Amiga when you are scrolling it. Okay, so this is also something we did in chapter 5. So he added this part to it, but it doesn't matter. The most important thing, as you can see, the transparency is happening also on the memory while we're scrolling it. Okay, like here you can see it happening quite easily here. Okay, and this is the previous demo that I was running, I think. Yeah, in fact, look, this is the previous image that we had, and probably if I continue I will find the old Amiga logo. I mean, I don't know, but it's just one of those things. Anyway, so as not to continue to waste time, because this, I would like to finish this chapter. It's a long chapter, and yesterday it took me 2 hours and a half to finish it, but there was more interaction probably also. So let's go to the book. I need to go to the book too. And we need to go to the example 5F with it. So let's scroll 5F down. And we are doing G. Is this G? Yeah. So here we have the usual print routine to print the text on the screen. Okay. So this was already explained in the last stream, but if somebody has any issues, please let me know. Which is further down, which is this one. Okay. This is the routine to print text to the screen. It's just taking a font, reading it, and then displaying it on a Bitplane. It's not doing anything special. This is our text. We load our font. It's find the font that we are using, and then it displays it to the screen. In short, I'm saying it. This is the routine, okay, that as you've seen in 5L, okay, it scrolls the bit plane up or down, okay. The part where I said that we can see the memory, okay, going up and down. So this is the routine that I have explained already. This is the part that goes down, this is the part that goes up, and this is the part where we check if we finished, we arrived at the end of where we want to go, and we change direction basically. As I said, he's using high res actually here to display the text. I forgot to mention that it was a high res image where we had the text, okay. But really nothing changed, and I'm going to show you the colors. So this is what he actually changed. This is the only difference between 6G and 6F. Only these colors changed. They were all blue before, and now he made them look more, he combined them better with the gray of the image. So nothing really changed. As I explained last week, but just to remind you, when we use BSS, okay, we are saving space on the floppy, but when the program loads, it creates a memory in memory, okay, this size, which is our bit plane of 320 by 256, okay. I think that's number 6G, and now we start with 6H. Okay, so let's go back to the Amiga and let's read 6H. We assemble it, and what we have here is just text on the screen, but we have more than one color now. And what you can imagine, we have two bit planes, okay, because we have 4 colors there, one on top of each other, okay, and when the colors meet, we see a different color. When they do not meet, we see a different color depending on which bit plane they are. So we have one which is black, okay, that is colored 0. Then we have one which is index 1, color 1, probably it's the green. Then we have the orange, which is probably color index 2. I mean, I'm just trying to guess here, but let's see. And the blue, which is color index 4, sorry, 3, and orange is 2. I hope I said 2, not 3. But that is it. Okay, so he's just writing, instead of 1-bit plane, he's writing on 2-bit planes now. So let's check the code. As I said, guys, when you do not understand something, just ask, okay? So we did 6G, we are doing 6H, okay? So my first note is here. So here, okay, we are setting the bit plane pointers, okay, for the first bit plane, okay? And here we're setting the bit plane pointers for the second bit plane, okay? So you can see BPL pointers and BPL pointers 2, okay? Bit plane 1 and bit plane, sorry, bit plane 2 and bit plane. So you can compare where they are. So this is where they are in the copper, I assume, or where they are actually in memory, and this is where they are in copper. And then we just populate that address, nothing else what he's doing there. Here, here, I mean, you guys know this. I explained it many times. We are just setting we are, when we kill the system basically, and we are making sure that we are compatible with AGA here. So no need to explain. This I have done it many times. Here we are. This is the print routine, okay, that prints to the first bit plane, and this is the second routine that prints to the second bit plane. That's all, okay? So we are just passing, you know, we have one routine and we're passing different parameters to it, but it's always the same routine. Nothing changed. After that, of course, this is the part where the system is killed, okay? Where, sorry, returned, where we said not killed. This is the part where we return to the OS. So we restore everything to the OS, which I explained several times now. This is our print routine, okay? The print routine that we had in chapter 5, okay? That prints text to the screen, okay? Which I even gave a small overview a few minutes ago. This is the text, and you're going to see 2 of it now. Why? Because we have one for 1-bit plane and another one for the second bit plane. You can see here. The difference is, so where they merge, okay, where they are, so let's see, Vita, and we should have Vita here, okay? So that means that they are on top of each other, okay? So that means, if I'm right, it should be blue. And we can check that in the colors of I mean, I'm trying to guess the colors here, it's funny, but we see if I'm right or not. I cannot really tell if it's blue. I don't think it is. Maybe it's blue because 4, it's stronger. This is orange for sure, so 3 I was right, and this is green, so yeah, this is blue. uh, okay, so I guess the colors. I need to play a game also while talking to you guys. Anyway, so that's what he did. I'm just making sure that I read all my notes. Yeah, basically, yes. Let's see if we are still. Now, this time, uh, for BSS, okay, instead of reading one, instead of allocating one bit plane when the program loads, we are allocating two, okay, because we have two bit planes, but they are not stored on the floppy. So when the program loads, it creates a block of memory with two bit planes, and this is the chunk. This is the code that tells it to create 40 by 256. So 40 is our width, 256 is our height. 40 times 256, which is the size of our screen, so times 2, to have um, 2 bit planes, basically. Okay, so we arrived here. What is my next one? Um, I think we have two examples here. So I am going to check uh, uh, we're going to show you again H, and we're going to see H1, okay, which is, he told us to add this part. I know what it does, but I'm just keeping it a secret, okay, because I know what he did. And I will show it to you in the code what this line actually does. It creates a nice effect, which you should all like, put it this way. So let's go back to the Amiga. Okay, we should, I'm going to show you H again, okay, just to show you the colors, okay. So you can see where is Vita. Oh, it's green. Vita is green. Sorry, I pressed the mouse button, so I didn't guess it. I thought I did, but no, I didn't. Uh, so yeah. Anyway, the colors are. Hold on, Vita is not the flashing one. I thought it's not the blue one. Okay, so where they merge, it's green. So I said it wrongly, but there is the blue when it is the second bit plane, I guess, um, for the color. The first is green for sure. Then we have blue, and then when they it's green, orange, blue, green, orange, blue. Yeah. So to uh, go to example H1 now. So this is code that I edit, okay? But of course he said what one can do. So I just wrote the code and followed what he advised. So what he did is, so the colors are a bit, they hurt the eye, but he did it intentionally, okay? Just to show you, and I'm going to point to it now, okay? Look where they meet, okay? For example, the letter T, okay? With the green, okay? So basically, he shifted one of the bit planes up. So remember, we had two bit planes, one on top of each other, but he shifted it up. And this is to show that you can create like an effect of 3D, okay? With by shifting a bit plane, okay? So actually, I will show you in the code. It's the same code as H, okay? This is H1. It's the same code as H with a difference, which I'm going to show. So I didn't do much, but that is what it creates when you add what he suggested. You can, it does give this effect of 3D, the colors of 3D basically, and he did it intentionally, as I said, so that you learn basically. Let me show you actually on the code now, because it's not on the book. So what he did, okay, he changed this line, okay, he added 40 times 5. So he shifted the second bit plane by, remember, each line, each horizontal line is 40 bytes, okay? So he shifted the bit plane by 5 um, pixels up, okay? We can even shift it, like, let's do it with 2, okay? And you're going to see that they are more on top of each other, and they are very difficult to read now because of the colors that he used, but that is to create the effect of 3D basically. But it's very easy to create it when you think about it. There is no extra code. You're just shifting one bit plane and you have this effect. I'm just going to return it back, because when I share the code it will be changed. But yeah, it's that is all. That's the only line he changed, okay? Let's do, so we finished H, and let's do I. So now we have a flashing color. Now you think, oh my god, is there a routine for this? Is there something? This is the same. Remember when we had the copper bars that were cycling colors? It's the same routine. He just applied the same routine on a color instead of on several colors. So he's really doing nothing except changing a value in one register. Okay, that is all. And I'm going to show you what he did. So if we continue with, so HI with it, we enter here now. Yeah. So same example as 6H. Okay, remember, this is how the book is. We always it's always in steps of increment. We always add something to the previous one, and most of the time the same routine with some improvement, not to the routine but to the way the Amiga works, or to the way the Amiga to some register on the Amiga. Okay, so this is the beauty, I think, of the Amiga, that the same routine, you can use it for so many things without thinking of doing anything else, because you just need to change the register on which it works, and that is all. So as you see, this is the routine that we had. So the routine starts from here, okay, to here, okay? This is the routine that cycles a color, okay? We've seen this routine several times, and he has a table, okay? He has a table. He cycles the color, so it starts from, I think it starts from the bottom and moves it up. So what's in here goes in here, and this goes in here, and this goes in here. It continues, and it cycles it, okay? But instead of shifting it here, this is what he was doing when we were doing the color cycling. Instead of shifting it here, he has a pointer, and each color we copy it into one register, okay? Which is this register, color 1, okay? So he's poking those values here every frame, and we get that effect. That is all. Before, we were using the same routine, but instead of poking it in the register of color index 1, we were poking it to the next available one to the previous one, basically. So if it's from here, we move it here, and this one moves here, and this one moves here, and it comes. But it's the same routine. Nothing changed. So, guys, sorry. Actually, I left the screen and I didn't switch to the book. So this is the code. This is Tomar. This is what um, Fabio Ciucci wrote in his book. Okay, and he took it from the Divina Commedia, of course. That's why it is there. I'm not changing anything. I'm using his book. Yeah. I'm just going to explain again that routine because I realized that I didn't change the screen. So this is what I was talking about. Okay, this is the routine. Okay, it starts from here, lampeggio. Okay, and till here. And basically, we are reading a table and moving it, each value, we are moving it into this address. Okay, that is all. And that's how he is achieving the effect of that is how he achieving the effect of the flash. Okay, so in this chapter he is explaining how to do horizontal scroll, but also he's explaining how to use tables. Tables are very important in, for those that use the Commodore 64 know this very well also, uh, um, to coding. Probably it's important to any assembly, but I only know 6502 and 68000, so I can only talk for those two. But probably it's the same thing for Z80, let's say. So that's all it does. There's nothing else in the code that I haven't explained. Yeah, this is where he's writing. So yeah, I'm just checking my notes to make sure that I'm not skipping anyone. And we arrived in 6L. Actually, no, there's another example. I think he changed the colors. Let me see. Let me put you back to the Amiga. And let's see. So we did 6I. Yeah, there's another one. 6I1. Yeah. So he changed the color. So basically the table changed. It's more fleshy and there's the red in it. But it's the same. It's just the same routine. Nothing changed in the code. The book is by Fabio. I'm just going to bring it in because I forgot to take it out from the shelf today because normally I have it in front of me. It's by Fabio Ciucci, aka Randy of RamJam. So if you're Italian, you should know RamJam. And it is corso completo di programmazione assembler in due dischi. Okay, so if you go on Aminet, you should find the book. It's available in PDF and also the sources. So you should be able to follow if you want. Follow me if you download it. Actually, I suggest this to everyone to download the book and to follow me through the book because of the number of examples and of all the stuff that there is in it. The book in total, there are two books. One is without the examples and one with the examples, and one is 400 pages and the other one is 1812. The one with 1872 to be honest. The other one is with all the examples, and the examples are well documented and they have also other things in them that it's like another book separate. Okay, so basically I'm going to show you that all the change is the you see now it is smaller. The table that we have for the flashing of colors, it is smaller. So that is why it was faster and the color was different. There was a bit of red in it, but the rest of the code is the same. Nothing changed. Okay, so we did 6i, we go to 6l. I'm just going to show you and then switch to the book. Okay, so 6l. So all this does is having this strip on the screen and flashing the colors. Why he's doing this? As I said, he's using tables and he is showing you the importance of tables. Nothing else, and I will show it to you in the code. I mean, eventually something is going to change. Okay, you're going to see a big difference in a moment because he's going to combine everything together. So because right now you're seeing small things and small things changing, but when you combine all the routines together, you're going to see something which is really cool. The last example is a small intro actually of this chapter. It's really a nice intro. The way that we know with the Amiga. So all these are going to take you there. So let's switch to the book. So in fact, I have a note that is the same code as the previous one, as 6. This is 6L, as 6I, just different tables. So you see the table, this is the table, okay? It's a bit different than what we had, and that we have only a strip in the center of the screen, which he's doing. So he's not loading any images now, doing nothing. He's just created a copper bar, but wide one, okay? And flashing the colors to that. That is all. So somewhere he's waiting at a certain position on the screen, as you can see here. He's waiting for line on the raster line. He's waiting for AO and then changing again to when it reaches CO. Okay, and that is our width of the bar to show the colors where he's flashing the colors, and the colors are always going into the color register 0. Okay, so nothing changed there. He has several examples, so I have a note here that tells me run examples which I made now, 6L1 and 6L2, with these new tables. So each table I'm just going to run them. Let's switch to the Amiga. We have 6L1. So now he's cycling more colors. Okay. Remember, he's reading this from a table. Okay. So imagine this effect with a scroll text on top of it. This is how the book builds things. Okay. So this is something that we can have in the background and something moving on it. That's one. And now we can read number 2, which is also the same thing but different colors. So nothing really changed in terms of code. You can see there's more maybe red than the previous one and a bit more yellow, but it's just a table and we are reading from a table. In a minute, as I said, things are going to make sense. Right now you are just seeing the code to let's say to build on a bigger block. Okay, so we arrived at 6L. and we did 6L, and we do 6M. I believe after 6M I have to stop and switch to the other book. Let's assemble it. Okay, so this is a bounce effect of the logo. Okay, ignore the this part on top of the screen. Okay, this part. As you know, I'm not using the original logo, so because I had problems in decompressing it, so that's why this is coming up here. But imagine if we had the proper logo, this will not show up. Okay, so just ignore that. You will see what he is doing here. He is reading values, okay, and changing the height of the window, okay, and by changing the height of the window, okay, at certain values, he creates the bounce effect. Okay, so it's the same routine that we had a few minutes ago to cycle the colors. It's the same routine that we had to change to make the color flashing. Okay, but instead of applying it on index color 0, now he's applying it on the display window start, because where the window is. Okay, so I'm just going to show you that. So 6M. So still same thing, reading a table. Okay, that's what it says here, and we are reading the same routine, and he's explaining the data, but I will explain to you the data, what it means in a minute. You can see this is our routine to display bitplanes, okay, which I explained several times. So this is to have the image on the screen, and here is our table. What he's doing, he's changing the, first of all, let me show you the register that he's changing. It should be, what is it? Okay. He is changing, sorry, I said he's changing the display window start and stop. That's an error, it comes later. He's changing the bitplane pointers, actually. He's changing these. Okay. As you can see, they are 0, and this is what he's changing. What he's doing, he's adding. Okay, so once he get the pointers, so here we are updating the bitplane pointers. Okay, this is the routine that displays an image to the screen. But what he's doing, every time he calls it, he is shifting with these values. Okay, as you can see, do nothing, and then remember, one line is 40 bytes, so we shifted by 40, and we shifted again and again and again and again, and then we shifted by 2 lines, 2 lines, 2 lines, and then 3 lines, 3 lines, 4 lines, 5 lines, 6 lines, and 8. When it reaches the bottom, okay, we do the opposite. Okay, so it's a reflection, it's a copy of what we had here, but with a minus in front of it. Okay, so -8. So as we had 8 going down, we have -8 to go up, -6, -5, -4. Remember, raster lines we are talking here, because 40 bytes are one raster line, and that is all. He's reading these values and putting them in the bitplane pointer. Okay, which is, let me see if I find it where he's putting. So what is the name of the table? So this is the name of the table, which he has up here. Okay, this part, and the bitplane pointers are here. Okay, this is what he's updating, and as you can see, the name is bitplane pointers. Okay, that is it's the same routine, nothing changed. He's just passing a different parameter to it, uh, which is a different register basically, but always the same. He has a flag. Okay, this is a flag that tells him um, to change direction. Okay, but nothing else. Okay, so that was 6M. We arrived in 6N, but I believe I need to switch to the other book now. So this is the same routine to read the Bitplane pointers, okay, and have them displayed on the screen. But then he's doing a shift, okay, and the shift is by reading this table, okay, and as you can see, okay, it starts with 0, then plus 40, then 2 lines. Plus 40 is 1 line, 1 raster line, then 2 raster lines, then 3 raster lines, 4 raster lines, 5, 6, 8, and then the opposite of it. So it's a mirror of what we have here, but with a minus in front. Okay, so it reaches the bottom and reflect and goes back up. He has this flag, okay, to know when he reaches the top and change. Okay, because the table he's only reading the values. Okay, that is all. Nothing else. And I'm going to show you. These are the Bitplane pointers where he's working on. Okay, and see the name Bitplane pointers. It is here, Bitplane pointers, and the table name. Okay, it's here. Okay, and you can see he's adding a 4 to the table pointer, but he's getting that. Remember, each one of these is a long word. Okay, this here long, so that's why he has to add 4. That is all. Yeah, I believe I covered it all again from the beginning. So let's switch to the other book. If you notice up here, I have the books. One is the 400 pages 404, and the other one is the 1872. If you buy the book online, you can only order this one. You cannot order this one. I mean, if you had to order this one and try to print it, it costs a lot. But this one, to be honest, it only costs £25, and it's very good. I mean, even if you do not understand Italian, okay, just for the sake of having the sources, okay, because in the end you have to learn. In the end, what you really need to understand is the sources, which is it. That is all. The text doesn't matter. You have me as the interpretation of it. Having the actual routine in the book and looking at it helps more than just having the source. So yeah, but anyway, I do not have any commission from the book, by the way, just in case. And the book, as far as I know, doesn't make any money from what I was told. It's just the actual cost of the print. It's only £25, actually $25, I think it is. So yeah. But I do not know now because I think it gets printed in America, and to send it to UK now, I do not know what that is. But when I ordered it, it came, I don't know, within not even 1 week. It came very quickly. So yeah, but I have it quite some time now. Okay, so we did M, and I'm going to explain what he's going to say here. So far, we have seen. So now we're going to do scrolling, okay? And scrolling the proper way, not as we did it in chapter 5. We were just shifting, okay? And he is going to explain how to actually do scrolling, which is, if you know the Commodore 64, horizontal scrolling on the Commodore 64 is similar to the Amiga. Okay, the Amiga has more registers, but it's very similar. Okay, the same mentality, doing a shift, and when we've done the shift, we move the screen to a different position, while on the Commodore 64 we copy it to a different position. On the Amiga we just update a pointer. Once we shifted 16, we just update the I wish the Commodore 64 had that, but it doesn't, unfortunately. So on the Amiga it's very quick to update, to do a whole shift of the screen. So basically, what we are going to talk about is how to do the proper scrolling, as we are used to see that smooth scrolling of the Amiga. So far we have seen the scroll happening through BPL con 1. Remember, it's the hour register that shifts the bit planes, basically, and it can shift odd bit planes and even bit planes also. So if we want to move part of the bit planes, we can do that also, something that the C64 doesn't have. So to shift the whole screen, we need to use BPL con 1 shifting plus the bit planes. So as I said, the shift register, which is BPL con 1, plus then update a pointer in the bitplane pointers. Okay, we already saw how to do scrolling up and down smoothly on the Amiga. Okay, so now we are going to do it properly horizontally on the Amiga, because as I said, we were only doing shifting of 16 bits. You can shift also, let's say you want to have a scroll instead of 16 of 8. You can do that, okay? You can shift of 8 like it is on the Commodore 64. You shift 8 pixels instead of 16 pixels. Maybe you have a particular situation where your tiles are only 8 pixels, not 16. But it's faster to do a 16 bit shift than an 8-bit bit shift. But it does work, so you can do that also. To do a shift, so once we shifted the 16 bits that we have for the Amiga, I was going to say for the Commodore 64, but it's for the Amiga, we add 2 bytes to the bitplane pointer. Okay, so if we are going to the right, okay, we so we are adding 2. If we are going to the left, we do -2. Okay, and the same thing on the register, we do from 0 to FF, or from FF to 0. It depends which direction we are moving. Okay, simple. Yesterday, because of, I'm going to show it to you, but it's a very crude diagram, and guys, I have arthritis in my hand, so when I try to draw a straight line, I do not, actually it's not in my hands, in my fingers. When I try to draw a line, it doesn't come straight. So I'm just going to show you the diagram that I did. Okay, this I did it live. Okay, so I'm just going to switch on my pen again, just in case I need to explain something. So basically, if this is our screen, okay, and we have either something on this side or something on this side, imagine we are shifting, okay, the 16 bits. We see this blue square coming here. Okay, once we arrive, okay, we need to do a plus, no, +2. Okay, and this becomes here, and then we start shifting again. Okay, imagine we have an image, okay, which is 640 wide, okay, and we are only seeing 320 of it. Okay, so we have 320, another 320 pixels to see, which is 320 is 40 bytes. Okay, so 320 pixels division by 8 is 40 bytes. So to move right, okay, we do -2, okay, and from 0 to FF. Sorry, from FF to 0. To do the opposite, okay, we do +2 from 0 to FF, okay. That is all. I'm trying to see if I missed something from this diagram. As you see, it's a very crude diagram, but it explains how it is done. Now, I am going. He actually does a routine, one routine, but remember, it's a copy of the same routine. Whether to move left or right, it's the same routine, but we are either making a +2 or a -2 on the bit planes. The register, the shift, is the same. We increment or decrement, but it stays the same because we are doing a 16-bit shift. So let's go back to the book. Okay. So this is our routine. Okay. Just to see. This is the routine. Okay. Of, hold on. No. This is where I should be. This is the routine. I think here. Let's see if I missed something here that I should have said. Of course, when we update the bitplane pointer, okay, when we add +2 or -2, okay, we need to update the shift register. Okay, so if it was FF, we reset it to 0, and if it was 0, we reset it to FF. Okay, so that's it. So this routine moves to the right. Okay, it's basically moving left or right. As I said, is the same, but one has a plus and the other one +2 and the other one has a minus. This is -2, I believe. Yeah, sub and 2. So we have our bitplane pointer. Okay, sorry, this is the bitplane pointer, and this is a check. Have we scrolled the 15 shift? Have we done this 15 shifts? Okay, so you can see he's comparing if we arrived at FF. If not, we continue shifting, and continue shifting, I'm going to show you that first, is this. We add 1 1, so one is for the odd bit planes and the other one is for the even bit planes. We add that to the register. So mio bp con 1, okay, my bpn bp con 1, mio, that's what it means, my, is the register where we are updating. Okay, here and now, okay, removing this part, okay, this part on top, removing this part on top, and removing this part at the bottom, okay, the other routine. Okay, this routine is the same routine to update the bitplane pointers. So there's nothing that you don't know. You have already seen this. The only thing is, when we get the bitplane pointer, okay, we are either adding 2 to it or subtracting 2 to it, but it's the same routine. Okay, nothing changed. This is what you need. Why do I like the book? Because it goes so in steps, in so nicely in the steps, in the way the routines are explained, that it makes it easy for someone to understand what actually is happening. Okay, so and then further down he explains it with a diagram. So first we are shifting. Okay, so this is BPL con 1 and we are shifting the register, okay, from 0 to FF, the odd and even bit planes. Give me a second, guys, because I forgot to switch one sound off. Okay, so so we start shifting. Okay, when we arrive at FF, okay, we reset it. Okay, we reset it so it becomes 0. But the bitplane pointer, okay, so here we don't add anything to the bitplane pointer. We either subtract or we add. In this case, is subtract. Okay, we subtract 2, which is a 2 bytes, which is 16 bits basically, and we continue like this. Okay, and that's how we have a scroll. Now, if we want to shift a screen, because sometimes we do need to this, but once only once, and the shift is of, let's say, 22 pixels, as he says here. So to shift 22 pixels in one go, it means we have to shift from 0 to FF, okay, then do a plus or minus 2, okay, depending in which direction, and then do another 6, okay. This is what he's saying here. I just took a note of it to make you aware that how to calculate it. Now we are going to see a scroll of 16, a scroll, a horizontal scroll. Now 6n, okay, this example 6n has got a lot of steps in it. Okay, so we start with 6n and then we go to 6n1, 2, and 3. So you're going to see some defects, and each time we are correcting a defect on the Amiga. The reason why there are these defects, because the Amiga has got lots of registers that needs to be corrected when you are doing scrolling. Okay, we have seen so far the screen displaying an image and it's fixed the image. Okay, we have seen it going up and down, but really shifting left and right, we haven't seen it. Okay, so we need to take care of certain registers, because so far we have always had the screen set up to display a fixed image. So let's go to 6n. Let's switch to the Amiga, and you guys need to switch to the Amiga, and then we read number n. Now look what's going to happen. The defect is here on the right hand side. Okay, that is because, you know, the what is coming in, we are seeing it coming in blocks. Okay, so we are shifting from 0 to FF. Okay, but then once we shift the screen by 2 bytes, we see that if I press yeah, you can see it the opposite way around. It's doing the same thing. Okay, so the reason why you're seeing this defect, okay, is because the screen is set up to have a fixed image. Okay, like the VIC that needs to read the data before it needs to display it on the screen, same is the Amiga. We are not telling the Amiga, hey, we are scrolling the screen, so start reading the data before. Okay, he's going to show a trick, okay, of how to not to have to change the registers, but we are going to suffer on one thing by doing that. But that is the first defect. Okay, before I jump to the next examples, okay, related to 6n, I am going to jump to the code, show you the code in the book. Okay, so we need to jump to the other book, and we go to 6N, horizontal scrolling. So to scroll left and right, first of all, this is the check, okay, to press the, if we are pressing the left mouse button or right mouse button, and to change the direction, okay. Nothing nothing that you do not know, but I highlighted it because we haven't seen this part for some time, okay. But it's just the check for pressing left or right to move left or right the horizontal scroll. Now this is the routine that we saw, destra, okay, to move to the right, okay. And then, okay, I did not highlight it intentionally. We have the routine, okay, which is a copy of this one, okay, moving to the left, okay. Okay, this is left, starts from here. The only difference is we are adding 2 instead of subtracting 2. Where is the subtract? Here, this line, okay. Nothing else changes. It's a copy of the same routine, okay. Now the registers that you need to take care of the Amiga. So this is the display window start and stop. This is where you tell the Amiga where is our window on the screen. It's not like the Commodore 64 that you have always a screen, okay. The Amiga, you have to tell the Amiga, hey, this is where my screen starts and this is where my screen stops. You tell it the window on the monitor how big it is, okay. While on the Commodore 64 it's always the same size basically, unless you put an interrupt in the middle of it and, I don't know, close it or do switch to a different screen or something like that. But it's always fixed. While the Amiga, you tell it how big the window is, okay. In fact, you can have a window bigger than 320 pixels by 256 pixels, but standard is 320 by 256 for PAL, or 320 by 200 for NTSC. So that's one register that we did explain in the previous chapter. Now we did not explain this register. We said, okay, accept the values, okay, we have in this register, okay, in this register. This is display window start, data fetch start, and data fetch stop. This is where you tell the Amiga, where you tell the copper actually, okay, when it has to start reading the data for the screen. If it's displaying something, as soon as the display window starts, it needs to have read it before, no, to be able to display it. So in the last chapter, I said, or the book said, that those values need to be the 38 hex and D0, okay. We are going to see that those need to change, okay, but for now he's keeping them the same, and that's why we are seeing the defect on the screen. Another thing is the modulus, okay, is left at 0, as if we have a fixed screen, but actually we don't have a fixed screen. To be able to display, you know, to be able to scroll 40 bytes, okay, and have another 16 ready, that means we need to read 42 bytes, not 40, okay. So the modulus also need to change. However, before he shows what values needs to be in these registers, okay, and for now you still need to accept, for doing horizontal scroll, this is the values that you need to have. Later on in the book he explains why. We have not arrived to the chunk where we explain the DMAs, how they work, and how we need to tell the DMA for the copper to read before, okay. So please bear with the book, not with me, with the book. I'm following the book. Okay, So the next, so you saw that defect on the screen, okay? So he's telling us, okay, so let's see, he's telling us, okay, this is further down, okay, yeah. So he's telling us, let's change the display window start and stop. Let's make the window smaller and we avoid those 16 pixels that we have in the beginning. So what is going to happen here? We are telling the screen to become, instead of 320 pixels, okay, but 304 pixels, okay? Because we are telling it to start not at 81, but at 81 plus 16. So we are cheating here. Now, if you're using the emulator and you have auto zoom, you think you have solved the issue. But if you go on a real Amiga, you will see what I am talking, and I'm going to show it to you on the emulator anyway. So let's do this example by adding 81 to the adding 16 to the 81 of the display window start. So we are adding, okay, so this register, instead of 2C81, is going to be 2C91, okay, display window start. Let's go to the Amiga. Read the next example. Assemble it. And you think, you know, oh, we solved the issue. Okay, we are on the emulator here, remember, and I have auto zoom. Okay, so the Amiga was never, you know, HDMI. It never had the picture of an HDMI, so I'm zooming the image here. So, and if I go to the other side, you can see that it is lost. It is fixed. But I'm just going to bring the emulator, the thing. So now I need to, guys, switch to the screen and bring the emulator panel up. Okay, so you are seeing the emulator panel. I have filter and I have auto scaling. Okay, if I do it no scaling, so as we know the Amiga, okay, look what's going to happen to the screen. This is how you will see it on the Amiga. Okay, so let's assemble it now. See, it is stretched on the X, I think, but you can still see what I mean. Does it display my mouse pointer? I need to show you the mouse pointer. Let me see if I can switch to the other no, it shows the same. Okay, so just note, it's very difficult to see, but you will, if you have good eyes, you will see it. The left side is wider than the right side. It's difficult to see, I know, but it's wider by 16 pixels. Okay, that's why unfortunately on an HDMI, because remember I'm streaming at 720 actually p, it's very difficult to see 16 pixels. Okay, but that is what is happening on the left side. The column from where the picture is coming in, okay, right now when it's coming in, this column is wider than the right hand side. Okay, you will see it very clearly in the Amiga, on the Amiga. Let me bring this back to what it was. I don't know if there's something else instead of let's do default actually. Yeah, you can already see it actually. You can already see on the left hand side, okay, the screen where it starts. Okay, so when I assemble it, you are going to see, look where it starts. It's more, I think it's more visible, but it is very, I mean, since it's HDMI, since it's 720 pixels, 16 pixels are very small to see in a vertical column, but it is wider. The left hand side is wider than the right hand side, so please take my word on it. You can see where the logo is going out from the right hand side, and you can see that it's smaller than the right hand side when it's coming in. So let's do auto scaling again. Auto scaling, not no scaling. Okay, and you can see we have full screen now. But that is a defect. Okay, that is if sometimes actually some people use this trick. Okay, you see some games shifted to the right. Okay, they are not centered on the screen, and that is why, because they do not have the right setup on the screen. Okay, so their display window start and display window stop, or their data fetch start or stop, or the modulus, one of them is not right. That's why you see it shifted to the right. Let's see now the next example. Now he fixes it. Okay, now he fixes it, and he's going to show us the right values that there should be. Okay, before, sorry, I just forgot to show you that the registers were, okay, what he did is the display window start. Okay, so I'm just going to show you that this was, instead of 2C81, it's 2C91. Okay, so he added 16 to 81. The rest, the modulus is still 0. Okay, and the data fetch start is still 38. When that should change, and I'm going to tell you the value in a minute, and this should return to 81. Okay, so let's read 6 and 2, assemble it, and now we really have the perfect horizontal scroll, whether it's left or right or left. Okay, everything is still the same. No changes to the routine. It's only the values that will change. Okay, and I'm going to show you the values now. Okay, so I'm going to show it to you on the code in the actual Amiga. So you can see that the display window start returned to 2C81. So that's how it should be. Okay, but display window data fetch start, okay, is not anymore 38 but 30. Okay, the y is still the 0. Okay, so that doesn't change, but the x is the 30. So we are telling it to read, it was 38 and now it is 30. We are telling it to read, in theory it is 16 pixels, because remember the x is 2 pixels per x is always 2 pixels, so we are reading 16 pixels before. Okay, and the modulo, okay, remember we need to read not 40 bytes, okay, but 42 bytes, but the last 2 bytes need to be repeated, so we do -2 because we said it. This brings the screen, this brings the number of bytes on the display window, on our window, to 42. Okay, but the last 2 we do not need to read them, and hence we do -2. Okay, that's basically it. So these are the correct values, okay, to do a horizontal scroll. Every time you do a horizontal scroll, this is what you have to have. The theory of why 38, from 38 we go to 30, it will be explained later, but it is the same. As we know, the VIC needs to read data before, same for the Amiga. So we did example 6N. I'm just going to look at the book. Just seeing my notes, going to my notes now to see those that I highlighted. So you can see, look, he's saying the 3 that we need to change is this. This has to be 30, okay? And this has to be -2 and -2. The rest remains the same. One thing that I didn't mention, okay, and I put it in red, when we are scrolling horizontally, we lose one sprite, okay? We don't have anymore 8 sprites, but we have 7 sprites, okay? Because of the way the copper works. There's more to it later, but just take that for now, that we lose one sprite when we move the data fetch start to 30, okay? That's basically it. We can start example 6.0, but before I do 6.0, I want to see if I skipped anything in the book. No, there's nothing to explain here, so I can continue till I'll continue with the examples and explaining the examples. So 6.0 is a dual playfield scrolling left and right, okay? So I'm just going to show it. So we have a screen, okay, that is actually 640 by 256, but our text is longer, wider, and because of that we are shifting it left and right. So the same thing as we had before. Before we had the logo that was scrolling left and right. Now we have text that is moving left and right. So we draw something to the screen, we type some text to the screen, and we are shifting it left and right. Nothing changes. I'm just going to go through the code. I'm just going to go through my notes to make sure that I told you everything. Sorry guys, I stayed on the same page and I forgot to switch to the Amiga. So I'm just going to show you the code again. Not the code, the example again. You can see it here, it's scrolling left and right, okay? When it reaches one side, it bounces to the other side. As far as I know, the mouse stops it, okay? The mouse only stops it, doesn't do anything else. We have a 640 by 256 screen, okay? And we are scrolling, so we have an image actually of 640 by 256 and we are scrolling it. We are only displaying 320 by 256 and we are scrolling it left and right. That is all. I'm going to show you the code on the book. Going through my notes, I think I didn't write any notes to this one. As I said, here we have an image of 640 by 256, okay, and we scroll it because our window is only white 320, and once we arrive on one side, we scroll to the other side. There isn't any. That is our print routine that prints the text to the screen. And then we have the scroll routine that we all know. And further down, we should have the actual scrolling routines. He's showing it with my color text doesn't look right, but we have our window, okay, but the image is longer, okay. So what we are doing is shifting it left and right. This is our display window, and we are shifting it. Once we arrive on one side, we change. So not really, nothing out of this world. Just going to see if there's anything. Of course, he has a flag. He knows how much we need to move left or right. Once we arrived, these are the flags, okay. Once we arrived to the maximum of the flag, we change direction. We have seen this routine several times. So that's the flag. And here we have the routine that moves left, right, and left, okay. The same that we've seen several times. And here, this is the routine that I told you about before, that print text to the screen. And this is our text, okay, that we are printing to the screen. Nothing else. So we arrived in 6p. I'm just going to show you 6p. Now I prepare you, okay? These examples, you are going to see them combined in an intro. And all of a sudden, everything is going to make sense. So I'm preparing you. So we are seeing text being printed to the screen, okay, at a slow speed, okay. Basically, it's the same print routine, but instead of printing the text and then showing the text, he is waiting for a frame, and then we write a letter, put a letter, and then write another frame and put a letter, and that is it basically. I will show you the code. Let's jump back to the book. So this is 6p. Our print routine, okay, that prints to the screen. And this is the delay. Okay, here is a delay basically. This is, there's a note here. Each line has got a 0 at the end, okay? So to help us, he actually even told us which line it is, the text. It's got a 0 because remember, to know that we arrived at the end, okay? That is something that he added actually. Before we were not seeing the 0. So now we do a check that we arrived at the end of our text. Notice that he returned actually he's doing a scroll as we did before and did before. Because we are just shifting bitplanes. Okay, so it's not we are not doing any shifting. We have a static screen here. So yeah, I don't know where I got it in my head that we are shifting. Maybe it's because I've been talking for 1 hour 45 minutes or more. Just to remind you guys, I'm just going to bring it to the screen if I manage before I continue. Just to remind you that till Easter, I am running these streams for a charity that takes care of people with mental health issues. Okay, just to help these people. because I felt I need to do something. I have a friend that is suffering from this, and I should probably advertise this more often. But I'm so lost in explaining the book that sometimes it comes to me automatically also. That's why I forget to switch your screen, guys. I start talking, and because I've done it yesterday and I don't know how many times I did it myself, I switch automatically. But anyway, just for those that maybe joined later after after I said this, I'm do not get any money, as I said. It goes directly to them. Um, Running this stream to collect money for this charity to help people with mental health issues. We might think that only older people get, I mean, men, women, etc. But actually, also children has got this issue. Okay, and this charity helps people with mental health issues through games. So that's why I chose it. Anyway, let's go back to the book. Okay. As you see, because we have a static screen, these return to the default values. Okay, the registers return to the default values. And we have a low resolution screen. As you can see, bit 15 is not set. If bit 15 was set, then we had the high resolution screen. That's basically it for this example. The reason why he just drew a screen with slow printing text is because in the demo you're going to see that, and everything combined, it will make it really nice. So please bear with me. There's only one more example till you see the demo. Okay, so if you're eager to see the demo or intro, please bear a few minutes. And remember, we are in chapter 6 and you are seeing this. Imagine if we continue with the book, what you are going to see. Let's switch to the Amiga and read the next example, which is we did P, so we do Q. Yeah, the last one before the intro. This code, okay, I'm just going to show you the code, the example first. But he's using a very, very nice trick here. Recalling old habits. Yeah, so this is a checkered screen we have of, remember, it is only, okay, one bit plane, this screen. You can see only two colors, okay? And it is made up of 8 bits, which are ones, and 8 bits, which are 0. So where you see the blue and you see the black, okay? That's one simple bit plane. Now we have another one, and this one is made of 4, okay, on and 4 off. I hope I'm saying it right, but I believe it is correct. It's 4 and 4 and sorry, the previous one was 16 and 16, and this is 8 by 8, I believe. Anyway, no, this is the 16 by 16. Okay, this is 16 on, 16 ones and 16 zeros. Here we have, this I know by heart. Here we have 4 on and 4 off. Okay, 12 off. Okay, but shifted. Okay, so that's why we create that pattern. Oops. This is 8 by 8. Okay, 8 on, 8 off. And this is 4 on, 4 off. This is 16 by 16. Okay, 16 on and 16 off. And then we have the 12 the 4 and or 12. So 4 on and 12 off. Okay, nothing else. I'm going to show you um, the um, the code. So that's what we saw before. We are in Q now. Okay, so the code. So he's calling these routines. Okay, each one of them creates checkered thing. Okay, on the screen, checkered boxes. Okay, on the screen with different patterns. So let's see each one of them. So this is the same routine we've seen before for filling the screen, okay, with a pattern. But here we have certain patterns. You can see here we are filling the screen with 4 on and 4 off, okay? We are moving a byte with F0 basically, okay? And then we are doing the opposite. Here we are doing 16 on, 16 off. Okay, move long. And here we are doing 4 on, 12 off. 4 on, 12 off. Okay, that's how he created the patterns. The rest is, I mean, is the fill routine that we've seen to fill a screen. It's just that when every time I press the mouse button, we jump from one to the other. That is all. Okay. So, and here we have one of the examples of the screen. Ooh, hold on. Hold on, hold on, hold on. I need to change the book. Yeah. So, because even I had an issue. I was talking and I didn't change it to myself, let alone for you guys. So, just going up. Okay, here we have the 4 routines to create the square grids. Okay. Each one creates a different pattern each time I press the mouse button. Okay. So, this is the first one. 8 bits on, 8 bits off. Okay, and the opposite way around. Okay, when it does one square. And the same thing is here, but we have 4 on and 4 off. 4 and then 4 off and 4 on. So the opposite to create the effect of checkered squares. Here we have 16 on and 16 off, and we should have 16 off and 16 on. Okay, the opposite again. And the same thing, we have 4 on, 4 off, 12 off, 4 on, 12 off, and then the opposite, 12 off, 4 on, 12 off, 4 on, to create that effect every 16 pixels in this case. And that's basically, this is the same. So each one of these, okay, I'm just going to highlight it. Each one of these, oh, come on. Each one of these is a fill routine, okay? I remember it's a repetition basically, but each one of these is a fill routine to the screen. So we've seen fill routines before, so it's the same routine, just filling up with patterns that might look nice, okay? So we are saving, okay, in having to load an image with this pattern because we have it already. We can create it. I mean, the Amiga is fast enough to create it. Sorry, Dexter, I didn't see your message earlier. I have a very small window where to see text messages because today I am the only one. I have no moderators, as I said, so because of that, to have everything on, my window is very small. So that's why I missed your message. But thank you very much for alerting me anyway. I'm happy to explain it again so you hear it twice in a way if I don't switch. What happens to me, I know certain things so much by heart now that sometimes my mind continues talking. My mind continues talking, and I for myself, I don't even switch the screen. I just talk. So it's funny, but yeah, that's what happens when you know, read the book more than once and you do this more than once. So we've seen all examples, okay? Now, when I switch, when we go to the next example, there is music, okay? Music we haven't covered, okay? It's the only thing he add to the demo or intro. It's actually an intro that we haven't covered yet. That comes in chapter 14. But I will explain the routines, the play routine, the 3 routines that you need to call, basically, just in case. So I'm just going to show you the final thing in the book for this chapter. Put the sound on, please. Okay, I'm telling you that there is some music, and I'm going to switch you guys to the Amiga so you see it. Okay, I'm going to assemble. Okay, and run it. I hope you're enjoying what you're seeing. I will explain it later, each routine, but just to make you aware, the bouncing, the text being printed, we saw it. The checkered flag screen scrolling left and right, we saw it. And also the text moving left and right, we saw it. And the bounce, okay? So we also saw these. So yeah, Dextra. Dextra, sorry. It's what you saw there, okay? It's all the routines that we did, okay? Just combined together. And I'm going to show them to you just to prove to you that I'm not inventing things, okay? And I'm going to say from which example each one of them comes from, okay? So first of all, this is our main loop, and that is calling the I need to switch you guys to the book first of all. Okay, so now that you are on the book, okay, you can see these are all the routines that we are calling, okay? So the first one, okay, we create these checkered boxes, okay, that we saw, okay, and we create a screen of 640 by 256 of them, okay, and later on we scroll it left and right. This is the routine, okay, this one, the green one, okay, is the routine to print the text slowly to the screen, okay? So we have seen that. In a moment I tell you which examples, okay, but just to remind you, this is the scroll left or right, okay, of the screen. This is, sorry, this one. This is, okay, the bounce of the text. We saw it with the logo, okay? But instead, after we print the text, we have the text bouncing up and down, okay? And nothing else. What remains is the 3 routines related to music. 1, 2, 3. So when you initialize, first you need to, like in the Commodore 64, the play routine for the Amiga works the same. You need to initialize it, then every frame you need to do an update to it, the empty music, okay? And then when you exit, you need to do empty end. Now the play routine, this is an old version, okay? It's very old version, I think one of the beginning ones for the P61, okay? If it is not the latest one, okay, for sure, but it works and I left it there, okay? I'm going to scroll down to show you what he did, okay? So here, okay, we have to print to the screen our characters, okay, which our screen is 640 by 256 colors. Sorry, 256 pixels. That is our text, and then you see lesson 6.0, okay, the routine that we had in lesson 6.0 to scroll left and right the checkered screen, basically. That's what he used. Then it's the same routine, nothing changes, okay? Then he uses the routine in lesson 6M, okay, to go up and down, okay? This is the bounce effect. And you can see actually, you know, we covered this, the first you skip lines, how much you want to skip, and then you skip them when going down and then going up. This is lesson 6Q, the one before this one, which is to create the pixels 16 by 16. You know, the square, sorry, 16 by 16. This is the routine, the include, okay, to have our play routine. Okay, that's the only thing that it's not covered, and it will be covered in chapter 14, as I said. There's nothing else. And that's part of the demo. Okay, so I'm going to bring back the demo to enjoy it, because now we need to enjoy now with our achievement. And let's assemble it. Let's enjoy a little bit this, okay? Guys, thank you very much. Okay, really appreciate you following me and having this patience with me. Thank you very much for following, and I hope to see you in the next weekend for chapter 7, which is about sprites. So thank you very much.